In this video, I'll be working through the question you see on the screen from the Pure Maths paper 3, specifically paper 3.2 from Cambridge A-level exams from 2023. I'll be doing all this on the board. Hopefully it'll be a lot like you're used to your teacher doing in a classroom. If you want other questions from this paper, you should be able to find it in a playlist in the description below. And if you find any of my videos useful, I'd greatly appreciate liking, subscribing, or even sharing it to a friend sitting the exams this year or next. Question 9 is a very large question, or more to the point, it's two large questions. The first part of that question is we're going to have to deal with a partial fraction. We're going to break this, what we see here, up into a partial fraction. And then for the second part, we're going to integrate this, but we're going to use the fact that it can be broken up into a partial fraction. Okay, let's start off with A. They ask us to express fx in partial fractions. Now, there's multiple choices we can make in this question. There's often two. Is there three ways sometimes? There's at least two ways we can deal with multiple parts in this question. So that means I could do this question 8 times. There'd be a lot of overlap, but there'd be 8 different videos to do this. I don't have time for that, unfortunately. Just behind the scenes, I'm expecting my second child in the next few days, so I'm really rushing to finish all the questions from this paper. So I'm definitely not going to do it 8 different ways. What you need to remember for partial fractions is there's a couple of forms you need to recognize. So you can, with a bit of study, and it's not too scary, a bit of study you'll go, these come up all the time. A partial fraction that looks like this can be broken into 2 different ways. The one we're going to use today would be a over, let's say, 1 plus 2x plus b over 2 minus x plus c over 2 minus x squared. This is what we're going to use today. What I usually use I usually use the form of this a 1 plus 2x plus, I shouldn't really use b and c because they're actually different letters, dx plus e over 2 minus x squared. That's what I tend to use when I'm solving this. I won't do that now because it does seem to be more common for students to use this way. Also, if I do this way, it's not as useful to use substitution later in the question, and we end up having to solve it with a 3-term simultaneous equation. And to avoid that, I'm going to ignore this way. If you want to solve it this way, go ahead, have a look at the book. You should find some other examples. A lot of the things I do in this video should help you as well. We're going to pick this way here. Now at this point I can do 2 things again. What I tend to do, I guess I'll do it just as an example over here. What I tend to do is I just imagine I'm multiplying this out. So we know how to multiply fractions. We get a lowest common denominator, which in this case would be exactly what's here. And I'm cross multiply. It's a bit more complicated in 3, but I do most of that in my head. And what I do is I just find what will make an x squared. And I think this guy multiplied by a, well, first of all, sorry, this term here, a, to get to this term, he'll need to multiply by this. And let's expand this out underneath here. X squared minus 4x plus 4. So a will end up getting multiplied by all of this. So where will the x squares appear? X squared times a will appear. I hope you follow me there. I'm going to do this a different way in a moment, so don't worry if you're not following this. Will b have an x squared term? So b needs to be multiplied by this guy and himself, I suppose. So he'll get to this. And let's combine them down here. They would be minus 2x squared plus 3x plus 2. So b would end up multiplying by this. So an x squared would appear here, minus 2b. C only needs to multiply by this guy to get to this term. So no x squared. There'd be no cx squared terms anywhere. And I do this for x. Let me speed this one up. A will get a minus 4a. B will end up with plus 3b. I hope I don't make any mistakes there. C will end up with plus 2c. And then just the numbers, A would be 4a, B would be 2b, and C would be just C. So this is what I tend to do, and I could have done this the other way as well. And then I just say, well, the x squared term must be 2. A minus 2b must equal 2. The x term must be 17. And the number term must be minus 17. That's how I tend to do it. I probably went a little far there now that I think about it, because the two branching paths I was talking about was, I tend to multiply this out and do it like this. A more common way seems to be to take this whole term here. I'll write this top row again. 2x squared plus 17x minus 17. And we take the bottom row and we multiply it by all three of these. So this would be the more common way, I think, students. Well, let's write it all in. A over 1 plus 2x multiplied by 1. I won't do this for everyone. 2 minus x. 2 minus x all squared. This will cancel with that. We can do that in our head, and I'll do that with the rest of them. And again, we multiply this bottom by the b term. One of the 2 minus x's will cancel, and we'll be left with b times 1 plus 2x. Let's put a little wall around this. 1 plus 2x multiplied by 2 minus x. And for the c term, we'll multiply this bottom by this. The 2 minus x squares will cancel, so we'll be left with c times 1 plus 2x. Now, from this point, you could do the same thing I did here. Find all the x squares. And in fact, we're going to have to do this at some point. You don't have to do all three of them though, after what we do here, but you are going to have to do something like this at some point. When we get to this point, we have something we can take advantage of here. If you think of this is a function, no matter what we put in. We can put in minus 3, we can put in 17, we can put in 1,000,000. We can put any value for x in. And it won't change A, B and C. A, B and C are unrelated to that. So basically I can put any number for x into this I want. And it should still work. So let's take advantage of that. You might think, well, put in 0. Get rid of all these x's. And that'd be good. But there's something even better we can put in. We could put in, let me write it down here. We can put x in, x equals 2. And x equals minus a half. Have a look where we get that. I picked x equals 2 because that will make this 0. It will make this 0. That will make this whole term 0, that whole term 0. That'll be good. Again, I picked minus a half because 2 times minus a half is minus 1. 1 minus 1. All of this will become 0. That's 0. All of this will become 0. It's going to be a big advantage to us. So let's do it here. Let's go x equals 2, and we'll write all this out again. Let's see, 2 times 2 times 2 is 8. 17 times 2, 34, minus 17 equals 0. 0 plus, let's do it here. 1 plus 2 2's is 5, so 5c. That's got to be fairly. Let's just stay on this side. Let's see, 8 plus, 34 minus 17 is 17, plus 8 is 25. 25 equals 5c. C is equal 5. Okay, we've solved one of them. We have one of the numbers. That substitution really helped us there. Let's try that again then. X is equal minus a half. Minus a half squared is a quarter. 2 quarters is a half. Minus 17 over 2 minus 17 equals, let's see. Oh, sorry, this one doesn't have a 0 here. This one becomes 0, this becomes 0, and we're left. I might have said this became 0 earlier, I apologise. This becomes 2 minus a half is 2.5, or 5 over 2 squared times a. Let's clean this up a little bit. I guess we have room to do it down here. Let's clean this up a little bit. Let's write the 25 over 4 for this guy. Let's multiply everybody by 4. This will become 2 minus 34 minus 68 is equal to 25a. Let's see, all of this adds together to be 90, 102, and minus 102 plus 2, so that's minus 100 equals 25a. A is equal to minus 4. Okay, we've got 2 of them. Problem at this point is we still don't know what b is. So you would have to at some point equate the terms. Find out all the x squares on the left, all the x squares on the right. Now I did that earlier, so we'll just take that here. But you could do the same here. All the x squares, we'd get an x squared, ax squared, ax squared. We would get minus 2bx squared, minus 2bx squared. And we'd get no x squares here. So that's where I got this. So I do know a minus 2b is equal to 2. Remember, all the x squares on the left is 2. All the x squares on the right. But we also know what a is. So minus 4 minus 2b is equal to 2, minus 2b is equal to 6, b is equal to minus 3. And that's it, except what a lot of students forget to do is write the answer. Now I'm a bit out of room, but I'll rub this out here and squeeze it in here. I don't know, I think you'd get full marks for this. If you got the examiner in a good mood, hopefully you do. But just go ahead and write the full answer. Fx is equal minus 4 over 1 plus 2x. I'm just writing this again, but filling in the letters. Plus minus, you can write minus there, or plus and a minus 3 up here. Either's fine. I guess technically it's better to put a minus there, but I like doing it this way. Plus 5 over 2 minus x squared. Okay, that's the answer to part A. That's a nasty question. There's so much that you can make slight mistakes. I do these questions on a piece of paper beforehand, and I did this question 3 times because I kept just doing silly things. I kept missing, like, I don't know, one of these numbers here, or I seem to remember instead of 5 over 2 I wrote 3 over 2, and my answer wouldn't work, and I'm like, it's so hard to find it. There's no great thing I can tell you here except practice. Take it slow. Just check everything, just really slowly. If you can do this question in 5 minutes, great. Spend 10 minutes though doing it. Just take it nice and slow. You have 5 marks. I'm not sure how long that gives you in the exam. Probably 7.5 minutes or so, 10 minutes. Take your time. Make sure you're not making mistakes. Okay, let me clean this off and we're going to do part B. I'll keep just this equation. Okay, for part B, they ask us to show that the integral between 0 and 1 of fx is equal to 5 over 2 minus natural log 72. Now, first of all, whenever they say show this, you can read that instead like they're asking you find this, find the answer. But here we're going to be nice. We're going to show you the answer just so you can check if you're right or wrong. So that's it. We're just going to find this answer. This is too hard. I can't do it without breaking it up. So thankfully we've broken it up already. So to answer this question, what we're actually going to answer is this question here. Minus 4 over 1 plus 2x and minus 3 over 2 minus x plus 5 over 2 minus x squared with respect to dx. So sorry, dx here. So this we can do. It's still some tricky questions in it, but we can do this. You can do this all in one go if you want. I'm just going to do 3 questions. I'm going to break it down. I'm going to do this guy, and this guy. And then at the end, I'll put it back together. So bear with me on that one. Also then, I'll do this slowly, this question. I'll use substitution. This is nearly identical, like they're, in the method at least. Not the answer, but the method of this and this is the same. So I'll do this one slowly. I'll do this one quickly. Because some of you guys will do it slow, some will do it fast. And again, this, I'll do it slowly with substitution. Now, some of you can do all of these in your head. If that's true though, you're probably not watching this video, so I will do it slowly. Right, so let's break it up. Let's start with the integral of 0 to 1 of minus 4 over 1 plus 2x with respect to dx. Actually, you know what? Let's forget 0 and 1. We'll just do that at the end. Let's just find the generic integral and we'll forget the constant and we'll put in the numbers at the end. So what's this equal to? How do you do this? Like I said, you can do it in your head, but don't try. Just do it. You have plenty of time in a maths exam. I know it doesn't feel that way, but you really do. Use substitution. This bottom row is making it hard. You all know how to solve 1 over x. It's written in your formula tables. So let's make it look like 1 over x. And to do that, let's replace this bottom row with a u. U is equal 1 plus 2x. And this is, we sort of just remember how to do this. It's very common. Do 20 of these questions. You'll start remembering. We differentiate this. du dx is equal to 2. Let's rearrange everything. We'll get dx is equal to 1 over 2 du. So now what we're able to do is we can replace this bottom row. This is equal to, let's just replace the bottom row first. We'll replace this bottom row with a u. We can replace the dx with a du and a half du. The top row, a minus 4. That's just a number. There's no x's or u's in that. So let's bring the minus 4 outside. Again, the half as well, just a number. Let's bring that outside. There. So now we're left with an integral that's in our formula book. The integral of 1 over x or 1 over u, like 1 over something with respect to that thing basically, is just equal, so this is equal, see, first of all, sorry, minus 4 over 2 is minus 2. This is equal to the natural log of u, the absolute value of u. And that's equal to minus 2 natural log. Remember, we substitute u. Let's just put it back. 1 plus 2x. Let's put it back there. That's the first one done. That's the integral of this guy. At this point, we could just fill back in the numbers. Again, I'll do that all 3 together. The second one, let's do the same thing, but I'll just do it a little faster. Put it in, should have it in this space. The integral of minus 3 over 2 minus x dx. Because some people do it this way. You might see your teacher do it this way. If you're getting confused, they're just doing a lot of this in their head. They're just saying to themselves, the integral of this, of something divided by something, will always equal natural log that thing, 2 minus x. The minus 3 is just a number, that'll stay out front. And I cheated, I substituted here. I used the chain rule. So to fix that, we're going to end up dividing by the derivative of this bottom row. And the derivative of the bottom row is minus 1. Over here, we divided by the derivative of the bottom row. That's what we do in integration in this sort of case. Is 2. In this case, it'll be minus 1. That's how they do it in their head. They just know, the 1 over 2 appears here. In this question, it'll be 1 over minus 1. They just know the bottom row becomes the natural log. And when you do lots of these questions, it just becomes common. So we get 3 natural log 2 minus x. That's it. And again, we can evaluate that at 0 and 1. Let's do the final one. Let's do this one slowly again. The integral of 5 over 2 minus x squared dx. Right, let's Let's take the 5 outside. Let's substitute that bottom row with a u squared. And let's do that over here. Let's go u is equal to 2 minus x. du dx is equal to minus 1. dx is equal to minus du. So instead of dx, I'll put in minus du. The minus can come all the way outside. I like to write this as minus 5. I like to write this as u minus 2 du. You don't have to. I just rather doing it this way because it's easier then to remember. Integration adds a number. Integration just adds a number to this. So we end up with minus 5. What's minus 2 plus 1 is minus 1. And then we end up dividing by this new number. So we divide by that minus 1. So that ends up being equal to minus 5 divided by minus 1 is 5. U to the power of minus 1 is 1 over u. Well, remember, we know what u is. 2 minus x. Okay, that's all 3 of them done. What I'll do next is I'm going to rub the whole board out. And I'll keep this term here, let's say, and underneath we'll write equals, and I'll put in the 3 numbers and we'll evaluate it all. Okay, before we go any further, a quick recap. Part A, they made us separate this into 3 parts. Part B, they asked us to integrate that. So instead we're integrating these 3 parts. Just what I did there, I did these 3 parts out separately. Now let's just write them all in one go. The integral, let me just check my notes though first. The integral of this guy was minus 2 natural log 1 plus 2x. The integral of this guy was plus 3 natural log 2 minus x. And the integral of this guy was plus 5 over 2 minus x. And let's put a big bracket around all this. And we'll evaluate it between 0 and 1. So let's remember, that just means we put 1 in for x. And we write all this out. And then minus, we put 0 in. And we write all of it out. So let's just do that. It's a lot easier than it looks. If I put 1 in, 2 1s are 2, plus 1 is 3. The absolute value of 3 is just 3. So we get minus 2 natural log 3. If we put 1 in here, 2 minus 1 is 1. Natural log of 1 is 0, so we can forget that guy. We put 1 in here, 2 minus 1 is 1. 5 over 1 is just 5. Okay, then minus. We put 0 in. So we put minus, 0 goes in, we get natural log of 1. That's nothing, so get rid of that. Minus, let's put 0 in. We get minus plus, so minus 3 natural log 2. And put 0 in, we get 5 over 2, minus that, 5 over 2. That's it, that's all of that evaluate. And that's pretty much the answer, except it doesn't look like, I won't bother writing it down, it doesn't quite look like the answer they wanted us. They wanted 5 over 2 minus natural log 72. So we have to combine some of this. The numbers are easy. 5, which is 10 over 2. See, that's 10 over 2. 10 over 2 minus 5 over 2 is equal to 5 over 2. That's good. That's what they wanted. The natural logs, though, are nothing like they wanted. So we're going to have to start adjusting this. You need to remember that 2 outside is the same as 2 inside with the power. So it's minus natural log 3 to the power 2. Do you follow what I'm saying there? We can put a 2 up here or a 2 up there. Same thing. It's one of our rules of logs. Same here. Natural log 2 to the power of 3. Let's move this over here. This becomes 5 over 2. Let's take the minus out of both of them. Minus natural log 3 to the power of 2 is 9. Plus natural log 8. And all we're left to do now is to remember our log rules. A log plus another log is equal to the 2 multiplied together. Natural log 9 times 8, which is 72. And that's the final answer in the question. The only reason you had to change from this, I suppose, up to this is they asked you to make it look like that. Other times the exam would probably be happy enough with this. Although I guess you could, these are just two numbers, you should be able to combine them. People who have better calculators, by the way, can probably put this, this line here, minus 2 natural log 3 minus 3 natural log 2, and I wouldn't be surprised if it'll do this for you. Mine won't, but I wouldn't be surprised if yours does. Okay, that answers this long question. There's a very real chance I made a mistake up here. Let me know if I did in the comments. There's a very real chance you're unsure about something. Ask me a question in the comments. I'll do my best to answer. Thanks for watching and have a great day.